A classic problem in artificial intelligence and robotics is to have your robot follow a line. This type of challenge is often used in competitions. An example shown is the Australian RoboCup rescue competition mat, and the robot is supposed to go around this mat avoiding various obstacles in an attempt to rescue someone by pushing them out of the large green swamp.
Our fusion robot can use its optical distance sensor to detect the difference between the dark and white areas of the line. How can we use this knowledge to be able to follow the edge of a line?
The sensor finds the edge of the line by continually crossing from the white to the black and then from the black to the white, and continues this process, and this way even if the line curves it will still find the edge of the line. It goes like this: white, cross the edge of the line, black, cross the edge of the line, white, cross the edge of the line, black, cross the edge of the line, white, cross the edge of the line, black, and so on.
You can see the red light from the optical distance sensor in the white area alongside the black line. Now, if we stop this motor and this one, we go round, fusion will turn around until the light is over the black part of the line. It now knows it's over the black part of the line. We can stop this motor and this one will go. And it's back over the white part of the line again. We can stop this motor and this will go back over the black part of the line again. And we stop this motor and it will be back to the white part of the end. And it'll follow down the edge of a line this way. So how do we use Blocky and Python to get our fusion robot to follow the edge of a line, a bit like this fusion robot is doing here? We will examine the Python equivalent of the Blocky commands. First, we go to the fusion control menu and bring down the Blocky start block. You will notice at the right hand side of the screen that this brings in the Python start commands, which import the fusion system and the fusion drivers that allow Python to talk to fusion sensors and motors. Next, we want a loop. We go to the Blocky loop menu item and select the repeat while true loop. You will see the Python equivalent on the right hand side. The Python pass command does nothing to the logic of the Python program. It is just a reminder to us that anything inside the Python loop must be indented to the same indent as the pass command. Next, we want a decision element. We go to the Blocky logic menu and select an if-do decision element. We left click on the blue star and click the else block and pull it up under the if block. Again, click on the blue star. You will see we now have an if-do-else command in Blocky. In Python, the equivalent is an if-else command. Again, Python uses the pass element to remind us to use the correct indent. To keep our fusion robot alongside the edge of the line, we need to make a decision based on the value of the light reflected from the link as read by the optical distance sensor. Go to the Blocky logic menu item and pull down the comparison element second from the top and drag it into our Blocky program. Next, go to the Blocky sensors menu item and select the optical distance sensor block and drag this block down and place it in the Blocky program. The Python equivalent generates a variable ODS underline A0, which suggests that it comes from the initial letters of the optical distance sensor connected to slot A0. You may want to change this variable name to something more relevant, such as rink light or reflected light, but you can't do that until later on when we are using the Python editor. We next change the comparison to greater than. In the previous tutorial, we found the optical distance sensor black readings at the edge of the sumo rink were about 77, and the white readings were about 953. Taking the average of these two readings, we get a value of around about 515, which we can use as the decision point. To add 515 to the if statement, we go to the Blocky maths menu element and add it to the end of the optical distance sensor statement. We can now type in 515. Note that your readings will be different because the light levels in your room will be different. Make your own readings for the black and the white sections of your sumo rink and substitute your own reading values in here. Now, let's look at the Python code. If the light reading is greater than, in our case, 515, the Python code between the if and else will be obeyed. Otherwise, the Python code at the same intent after the else will be obeyed. Now, if the optical distance sensor reading is greater than 515, the optical distance sensor will be above the white area of the rink. And we want to, in that case, stop motor 0, if we're using the standard build, and put motor 1 moderate speed forward so that fusion will swing over so that the light is crossing over into the black area of the line. To make the light under the optical distance sensor turn towards the black line away from the white area, we choose M0 as 0 and M1 as a speed of 50. Now you notice that the right and left are the opposite to what we've shown in the diagram. This is because Modern Robotics, or whoever wrote the software, has looked at the robot from the back. We've looked at it from the front because that's where the sensors are, and we believe we can show you a better idea what's going on with the filming from the front. So any confusion is our fault. Sorry about that. Now, when the light under the optical distance sensor is on the black, we want the motor speed of M1 to be 0 and the motor speed of M0 to be positive. So let's get those down. And this is what the Blocky program will look like. We'll put a small wait after each of these of 0.1 of a second, 1/10 of a second, to slow the program down a little bit. And this is what the Blocky program will look like. Now, the fusion program looks like this. If the fusion reading and the optical distance sensor is greater than 515, it'll be over the white area, and M0 equals 0 and M1 equals 50 will turn this towards the black line. Now, if the optical distance sensor reading is less than or equal to 515, this part of the code comes into play and M0 becomes forward at 50, M1 stops, and the optical distance sensor will turn away from the black line towards the white area of the arena again. So let's take a look at this and see what fusion does when we start this program off by clicking on the green triangle. Fusion did do a good job of following the line, even the curved bits, but it did wobble a little bit from side to side. Let's try running the program again without the 0.1 second delays in either the Blocky or the Python, and see if Fusion follows the line a little more smoothly. Notice there is less side-to-side wobbling. We now have Python code that we can use to teach our Fusion robot how to follow a line. Thank you for watching.